Welcome to Lesson 5, Le Chatelier's Principle. Our lesson objectives determine the shift in equilibrium when a stress is placed on a system and determine the change in products and reactants when a stress is placed on a system. Le Chatelier's principle says that if a change, meaning a stress, is imposed on a system at equilibrium, the position of equilibrium is going to shift in a direction away from that stress in order to reestablish equilibrium. So we could have a forward shift towards the products or a reverse shift back towards the reactants. So different types of stresses that we could have. One is concentration. We could either increase the amount or decrease the amount of either a reactant or a product. We have temperature. We can increase the temperature or decrease the temperature. And for pressure, we can increase or decrease pressure. And that's only going to affect gases if they're involved. So let's look at determining some equilibrium shifts. And the first one we're going to look at is using concentration. So concentration is the amount of something. So if a substance is added, if we increase the amount or concentration of one of our substances, then the reaction is going to shift away from that side in order to relieve that stress and reestablish equilibrium. If we decrease, meaning take away a substance, then the reaction shifts back towards that side we just took away from in order to maintain or reestablish equilibrium. So let's look at our first example. We're going to increase the concentration of one of our reactants. Reactants are on the left-hand side. So we're going to increase CO. When we add more CO, in order to reestablish equilibrium, think about what we did in class in terms of that ratio that has to be maintained for equilibrium. In order to reestablish that ratio, we have to shift equilibrium to the other side. So when we add to one side, it's going to shift away to the other side. Now, what happens to the amounts of all of these things? Well, when we shift to the right side, we're going to make more of our product. So all of those are going to increase. And in order to make more of our product, everything on the reactant side decreases, because we're going to use these reactants to make more of our product. So you watch here, as we increase our reactant, they start to get used up in order to make more of our product. So that trick is add away. Whatever side you add to, we're going to get a shift away from that side in order to reestablish equilibrium. So now we're going to increase the concentration on the other side, on the product side. So we're going to increase the amount of CO2. So if I add to this side, equilibrium is going to shift away to the other side. And in doing so, everything on this reactant side is going to increase, and everything on the product side is going to go down and decrease. Now let's look at what happens when we decrease concentration. We're taking away. So let's look at the reactant side first. We're going to decrease the amount of oxygen. So we start taking away some oxygen. In order to keep that ratio, in order to reestablish equilibrium, we're going to get a shift back towards the reactant side. So we're taking away, shift back towards it. And so everything on the reactant side is going to increase, and everything on the product side goes down. Because again, the only way that you can make more of this oxygen to replace it is I have to start breaking apart our products here. And lastly, let's look at a decrease in concentration on the product side. So we're going to decrease the amount of CO2. And so we decrease the amount of CO2, we're going to get a shift back towards, take away, towards that side. And so everything on the product side increases, and everything on the reactant side is going to go down or decrease. Let's check our understanding. Can you determine the shift in equilibrium when concentration is increased or decreased? And can you determine the change in products and reactants when we increase or decrease concentration? Now let's look at the effect of changing temperature. So recall that in endothermic reactions, heat is on the reactant side, and in exothermic reactions, heat is on the product side. Heat is considered a reactant or product in these equilibrium shifts. So let's look at an example of increasing temperature. So if you look at this reaction, we have heat on the right-hand side, and so therefore that's exothermic. And so when we increase temperature, just treat this like a substance, and so we're going to increase this side. So we're adding to the product side. And we know in our previous examples, when we add to a side, it's going to shift away from that side. So if we add to the product side, it's going to shift away to the reactant side. And so we're going to make more of all of our reactants here. They all go up, and then our products here start to get used up, and so they decrease. Now, if we decrease temperature, because we have the heat on the right-hand side, by taking away some of this heat, we're going to get a shift back towards this side to replace that heat that was lost. And so everything on the product side now is going to increase, and everything on the reactant side is going to decrease. Let's check our understanding. Can you determine the shift in equilibrium when temperature is increased or decreased? And can you determine the change in products and reactants when temperature is increased or decreased? And lastly, we're going to look at changing in pressure. Now, this only affects gases. So an increase in pressure causes a shift away from the side that has more moles of gas. And a decrease in pressure is going to shift back towards that side that has more moles of gas. So let's see an example. If we increase the pressure, what's going to happen? So first look at the reaction. We see that we have gas involved, so we know that pressure is going to affect this reaction. On the left-hand side, we have 2 moles of CO and 1 mole of oxygen. So a total of 3 moles of reactants and only 2 moles of our products. So overall, the reactant side is going to be affected more than the product side. So just like when we talked about changing the temperature, we're going to say that this side now is the side that's affected. So by increasing pressure, we're going to get a shift away from this higher side. So adding pressure away, we get a shift to the right, and we're going to make more of our products. And so all of our products increase, and our reactants are going to decrease. And we can see that here as we increase pressure, and we do that by changing our volume. You can see what happens here. As we increase pressure, reactants A and B start to collide more, and in doing so, start to form more of our product AB. Now let's look at what happens when we decrease pressure. Again, the side that has more moles of gas is the reactant side in this example. So by taking away pressure, take away towards, it's going to get a shift back towards that side in order to reestablish equilibrium. And so now everything on the reactant side is going to increase, and everything on the product side is going to decrease. Let's check our understanding. Can you determine the shift in equilibrium when pressure is increased or decreased? And can you determine the change in products and reactants when pressure is increased or decreased? And lastly, what happens when we add a catalyst? Well, a catalyst is going to speed up the reaction, but it's going to speed up both reactions, the forward reaction and the reverse reaction. And it does so equally, so equilibrium is going to be achieved faster, but there is no shift in either direction. So in the reaction we had in class with our equilibrium tubes, which is this here, so we're going to get to this equilibrium point just faster, but again, there's no shift in either direction towards the reactants or products. At this point, you should be able to determine the shift in equilibrium when a stress is placed on a system and determine the change in the products and the reactants when that stress is placed on a system.